I'm Anthony Cangelosi. I'm the Group Product Manager for Microsoft DevBox and Azure Deployment Environments. Software development's been changing a lot over the last few years, and so is the way that we work as teams. Hybrid work has become kind of one of the primary ways that many developers work today. It brings a lot of benefits for developers, but it also has a set of challenges with how we get tools and resources and devices out to developers that creates challenges for developers and IT alike. On the developer side, developers are really trying to get into a workstation and get their environment up and running as quickly as they can so they can get into their flow and stay inside of their flow. Now, slow setup and onboarding times has always been a challenge for new developers, but when you combine that with distributing hardware out around the world to remote developers and the supply chain challenges, it only compounds the issues, making it worse, turning a problem that used to be a problem for a few hours of debugging with a team member in the office to one that now takes days or weeks to get up and running. Now, we don't all have access to the same level of hardware and to the same kind of gear to run with. Some of our developers are running on aging legacy devices or have a slow internet connection. This means that our team members may be spending hours building or syncing their code around with their teammates around the world. And the truth is we're all working on things in parallel. You may be working on a feature branch, building a new feature, a bug comes in, a prior one issue that you have to go and address and tackle. You have to stop what you're doing and switch context. That switching of context can potentially poison your environment as you have to go and get your bug from an earlier version of your application up and running, leaving you hours to have to go and recover and get back up and running again. That's just time lost taking you out of your flow. Now, our friends over in IT are struggling with some of their own challenges. They really want to give us the flexibility that we need as developers to be fast and agile, but they need to do this and keep our environment secure at the same time. Now, this can be challenging with so many different kinds of hardware and environments that our developers need to get up and running. You may have one team over here that's working on an AI project, trying to get an AI project with some GPU to be able to do some diagnostics on some large data sets. But at the same time, a few weeks later, you may switch over and need to convert your application from Intel over to ARM. These changing resources mean that developers need to be moving quickly from device to device. Now, many of our engineering systems haven't been built for a remote-first development team. And so this puts a big strain on IT teams to deal with all the support requests that are coming in. Add all of this complexity into our remote environments, and it's ripe for attacks from malicious actors that are trying to take advantage of our systems. And so IT teams need to be able to identify security threats as they come in for developers that are running anywhere in the world. Now, there aren't a lot of organizations that have the scale and the capacity to deal with and solve all of these problems while also addressing their customer needs. And at the same time, those that do often would rather put that energy and resource towards actually solving their customers' problems themselves. And so that's where Microsoft DevBox and Azure Deployment Environments come in. Two services that help you take advantage of the cloud and bring the scale and elasticity of the cloud into your engineering systems. On the one hand, we have Microsoft DevBox. Microsoft DevBox lets your developers self-serve and provision their own high-performance developer workstations in the cloud. These are ready-to-code development environments that have all the tools you need to build applications for your specific project. The images that run and power these dev boxes are built and managed by your team. Your team can put any of the software that they can run on Windows onto these dev boxes. So any IDE, any database tooling, internal apps and configurations they need, they can build so that they have a ready-to-go environment that's always up to date. Now, these dev boxes are centrally managed by your IT team. They're enrolled into Endpoint using Intune. So all of your group policies, all of your conditional access policies are there so your IT team can manage them the same way they manage all of their physical devices. On the other side, we have Azure Deployment Environments. Now, Azure Deployment Environments lets you do a lot of the same things for running and deploying your application infrastructure. Rather than having to manually configure an application environment yourself, Deployment Environments lets you take a template that's built by you and your dev infra team, and it takes care of deploying that environment on your behalf. So you don't have to worry about how to configure your application. You just need to deploy your app into it and figure out how to get your code running. It also takes care of deploying that on behalf of the user. So IT doesn't have to give broad access to the entire subscription. They can have an identity do the deployment on their behalf so that it gets deployed into the right subscription for the right project. Again, developers don't have to think about where their resources need to go. They just need to focus on what they need to build. So let's take a look at a little bit about how this works in DevBox and Azure Deployment Environments. So I'm going to switch over to the developer portal for Microsoft DevBox. The developer portal lets developers kind of self-serve and create their own developer workstations that they can access and connect to from anywhere. These project-specific developer workstations have everything a developer needs built into them. So here, for example, you see I have 2 workstations already running. I have my main development environment for the podcast app that we've used for a lot of our demos here. And I needed to work on a project to upgrade some of our dependencies. So I've created a secondary box that I can go and do that work and test those changes without interfering with the feature work that I was doing earlier. And I can keep those environments separated and isolated. Now, I can self-serve my own dev boxes, as many as my enterprise or team will allow me to create. And I can create dev boxes from any of the projects that I'm a user member of. So I happen to be a member of the Orchard Core project, the Podcast project. Each of these have their own set of dev box definitions that are each tailored and customized for building those specific applications. Now, one of the key ingredients for the DevBox service is this idea called a DevBox pool. Now, this cold pool of devices has 3 ingredients that give you a number of different options of how you can set up development environments for your team. The first is the image that gets deployed onto the DevBox. The second is the SKU, or the hardware that we're using for it. And then the third is the network connection, ultimately a virtual network behind the scenes that's getting injected into that VM that's getting provisioned for you. Let's talk about how some of those come together. Here you see I have a few different named DevBox pool. I have a backend DevBox. I have a data engineer DevBox. The backend DevBox has an image with Visual Studio and all the tools for building our backend services. The data engineering DevBox, that image on it is running SQL Management Studio and Azure Data Studio with a connection specifically for connecting to some of our on-premise customer data. And then finally, our front-end dev has VS Code and some web tools running on it for our web devs. Now, the second is the SKU I talked about. So you see here our data engineering has a slightly larger disk, and once we introduce higher-end SKUs, it'll actually use one of our higher-end SKUs as well. Our front-end dev is using a lower-end, lower-count core for some lower cost and cost savings there. The third piece I talked about is the network connection, or the virtual network. This is a really powerful piece of Microsoft DevBox because it gives us a bunch of options around how we can define the security boundary of the dev boxes that we're using. So while most of these dev boxes have access to the public internet, we also have this privileged access workstation pool that we've created here that has a custom secure network on it that only has access to a few limited endpoints inside of it. It doesn't have access to the internet. It allows our developers to diagnose production environment issues when they come up in a secure, dedicated, isolated environment. I'm going to go ahead and create a new dev box inside of our West US3 region, which is our closest to us. I'll call this my bug fix dev box because maybe I just got an issue that came in that I need to create a new dev box and keep that work separate from my primary feature work. Now, it takes dev boxes about 20 minutes, maybe 30 minutes for them to provision. We're working constantly on reducing the total time for provisioning dev boxes. But what's happening in that time is actually the service is taking care of joining that dev box into your domain. Whether it's an AAD native domain or it's a domain controller on premise, it'll take care of joining that domain for you. It'll also enroll that dev box into Intune for you. That means that your dev boxes that your team members are using are all being managed using the same group policy, the same conditional access policies that you're using to manage all of your devices in your existing infrastructure and IT domain. Now let's go and connect to one of my existing dev boxes I have here already. I can connect to the dev boxes from one of 2 ways. I can either use the browser, and that's great. I love that when I'm on the road or away from my desk and I need to get back and make a quick change on my workstation, I have the full power of my workstation that's available to me anywhere on the road. Or I can connect to this from within a Linux workstation if I'm natively logged in and I need to connect back and make a quick change. I can also connect through RDP. Now, RDP is a native application. It's running locally on the desktop, and this lets me take advantage of all of the capabilities natively available on the OS. It's available on Windows, iOS, Android, and Mac OS, and I can connect here. Now, let me sign in to this. Some of the things that you can take advantage of with the RDP client is, first of all, if I was logged onto the local machine with the same identity as the one I used to sign in here, it would actually use Windows Hello to log me in, so I don't even have to enter my credentials most of the time. The other thing is it takes advantage of 4K, high DPI, even multi-monitor support is available. So you can really take advantage of your full development rig from within this experience. Now, I've just logged into this dev box. Now, this isn't just a vanilla Windows image. This is actually a developer image that we've downloaded or using that's been pre-built for Visual Studio users to be able to use to have everything they need to build just about anything you can build with the Visual Studio toolset. This image has on it, and it's available in the marketplace for developers. It's available in the Azure Marketplace as the Visual Studio images. It has on it Visual Studio. We have a version with 2022 as well as 2019 available. We have Pro and Enterprise versions available in those images. The images are built in with all of our PowerShell and Azure CLI tools. You can see it has VS Code. It has Git for Windows built in. It also has nested virtualization enabled on these because these dev boxes actually support cross-platform development as well. Now, I've manually installed Docker Desktop on this particular image because I'm able to actually build my container images and do my cross-platform development from this machine. It even has the developer mode enabled because this is really a developer workstation. Now, I've also just recently cloned down the source code for this project and pre-built it, but we're actually working on building a definition that will check into the podcast repository that will actually build the entire end-to-end workstation, including all of your source code and binaries, so that you can actually get right into your development and start incrementing your code, saving all the time of building your container images. All right, so with Visual Studio running, let's take a look at how this works a little bit behind the scenes before we go in and actually start making some changes. So I'm going to move over here to the Azure portal and talk about some of the unique things that you can do with this service as an administrator of Microsoft DevBox. Everything in Microsoft DevBox kind of anchors around the Dev Center. The Dev Center is kind of like the organization inside of GitHub or the organization concept in Azure DevOps. It's a high-level unit that you can use for your entire company or for a business unit that brings together all the projects that your teams, oh, you can get out of the way, stop that. All the projects that your team are working on. And I can create new projects for different groups of developers within our team. Here we have the podcast application running, and we have the podcast project, and all the users that are a member of the group that have access to use this project will be able to see and create dev boxes from the pools that we saw earlier. Now I can go into the DevBox pools, and I can even see which dev boxes have been provisioned against each of these pools. You can see my main dev box here, as well as a few of the other dev boxes for my team members. Now, one of the questions we often get from customers is, how do I deal with contractors that I need to work on a project and contribute for a short period of time? I need to get them a full working development environment for my complex application, but I don't want to send them a dedicated machine because I have to figure out how I get that device back when our contract is over. I'm also worried about giving them access to their devices into my corporate network, because that means I'm letting unmanaged, insecure devices potentially into my infrastructure, creating more risk for my team. And so that's one of the great things that DevBox allows you to manage, is I can actually create a dedicated project for unique groups of users with their own sets of permissions. So I'm going to go and select the right subscription where my existing Dev Center is running. And let's select the Contoso Dev Center. And we're going to put this in the same Dev Center, but we're going to call this the Podcast Contractor Project. We'll create this. This will take just a moment or two to actually create that. And once this has been provisioned, I will have a project where I can set unique permissions that only the contractors on our team have access to, and that are more constrained and restricted for their use case. So I've got my project now set up. Let's go into Access Control. And let's give our contractors the role assignment for a DevBox user in this particular Dev Center. Select the members, and they are part of, we have an AAD group here for our contractors. And so any users in that podcast contractors group that gets added to there will also be able to access our developer portal and create dev boxes from this one project only. Now, the last thing I need to do is I need to give them a pool of dev boxes from which to create their own dev boxes. Now, one of the things is I can take advantage of all the work that I've done in my internal team, because they're going to be working on our back-end services. So I'm going to use the existing back-end definition that I created for my internal team. So this has the image that's been pre-built with all the tools that we need already on there. It also has the 8-core CPU. If I wanted to have a lower or a higher CPU for this group of developers, I could change that and create a unique definition for them. Now, the one thing I will change, though, from our internal team is I'm going to use this more secure or more restricted network connection for our contractors. Our contractors don't need the same flexibility as our internal developers. They only need to be able to access a few specific endpoints from my application. So I've configured this firewall to limit their network access to only those specific endpoints that they need, further reducing the risk of anything potentially sending information that I don't want outside of the network. Now that little label is getting in my way, but the second thing I want to show you is that I can also define the level of user rights or access on that dev box. Again, these developers don't need the flexibility of my internal full-time developers, and so I'm going to set it to standard user because I'm already deploying all the tools that they need to build the application, so they shouldn't need to add anything else into that environment. Now, the last thing that I'm going to do is I'm going to set an auto stop time. This is a new feature that we'll have coming out very soon for DevBox in our preview. And it allows me to set a time of day when these dev boxes should shut down when they're not being used. So we'll set that to 5 p.m. and these devs are on the East Coast. So we're going to set an East Coast time zone of, where is New York City? Havana, New York. There we go. Great, so I've set my East Coast time zone. And now, as these dev boxes are running at 5 o'clock in the local time zone, they'll actually shut down automatically. But we're focused on developer productivity. So they won't just arbitrarily shut down a running workstation where a developer is getting their work done. It'll send them a notification first, giving devs a chance to be able to skip or delay that shutdown so they can keep getting their job done when they're busy, but us not wasting compute for resources that are not being used and are sitting idle. Okay, so that was a quick rundown, an example of some of the things you can do to be able to provision your own developer workstations using the Microsoft DevBox service. Now let's talk a little bit about how you can do some of the same things with the Azure Deployment Environment. But first, let's talk about this application, the podcast app. It's a pretty complex application. It's got Kubernetes services, SQL Azure DB, SignalR, all running in an application. And if I was a developer joining the team, having to set up this environment ad hoc on my own is pretty complex. It's pretty time consuming and it's error prone. I might misconfigure that environment. And on the best day, I might misconfigure and not be able to deploy my application. On the worst day, I might misconfigure it in a way that I've left open a security vulnerability in my application. And so the way that enterprises will often deal with that risk is they will lock everything down. They'll say, okay, you know what? We're not going to let just anybody create resources in our subscription. We're going to have our dev infra team or IT admins do the provisioning for you. You as a developer can go submit a ticket to get one of these set up. Well, this just gets in the way of the agility and the speed that developers need to be productive. And so that's where Azure Deployment Environments come in. It allows developers to self-serve on demand the application infrastructure they need to deploy and run and test their application in what is a real running testing environment. So let's take a look at how that works. I'm going to switch back over to my dev box where I'm connected, and I'm going to come over to the developer portal again here. We're going to go to create a new deployment environment. Now, there are two ways that developers can create deployment environments. They can create deployments ad hoc using our developer portal UI. They can also use the developer CLI, and we'll see how both of those work in just a second. From the UI, they can create new environments for their project, and there are a couple pieces of information they need to set up here. First, they pick which project that they're focused on. Developers don't need to think about what subscription they're a part of or which resource they need to go in. They just know what project they're a member of. They pick their project, and that project defines the next piece of really important information, the environment types. Now, here a dev can pick which environment types they have permissions to. And when they pick an environment type, that connects up and says, for this particular project, which subscription should the service use to provision that environment for the developer, and which identity to use to actually do that on behalf of the developer, allowing the service to do it on their behalf so the developer doesn't need general contributor access to the whole subscription. The last piece of the puzzle here is catalog items. So what catalog items are basically an ARM template with some metadata around them that define all of the infrastructure for the podcast application. Anything you can define in an ARM template, you can put into a catalog item and you can provision with Azure Deployment Environments. Now, the UI is one way that you can do that for ad hoc, but I want to show you how we're using the CLI in a really innovative way to integrate it into our GitOps flow. Let's come back to Visual Studio over here. And I've got Visual Studio running, and I've got my solution open. Let's imagine for a second that our marketing team really wants to do a push on superlatives. And so they want us to really kind of emphasize that we are the first podcast app written in .NET. So let's go ahead and search for our landing page. And I can bring up my landing page here. And I'm going to search for our first announcement here. We are the first podcast powered by .NET MAUI. And so we really want to emphasize this. This is the very, very first podcast app written in MAUI. So let's go ahead and save those changes. And I'm going to move them over to a development branch where I'm going to push these changes up. And it's going to be our marketing changes. And let's create that. I love how Visual Studio kind of detects that I had some uncommitted changes and actually moves them over to the branch for me. So now I've got my branch set up. Let me go ahead and commit those into this dev branch. Marketing changes. Let's go ahead and commit that. And I'm going to push that up to my remote host. So now my changes have just gotten pushed up into our GitHub fork that we've created of the .NET app. And let's go and take a look at what's going on over there. So moving over to GitHub here into our project, great. I'm going to go into Actions, and that's because here in Actions you see that about 15 seconds ago a new deployment environment was created. What we have here in this sample repository is a workflow that's been configured to actually create a dedicated deployment environment for me each time I create a branch, and then builds my application and deploys that application into that branch for me. So as I'm making changes, I can see those changes running live in that environment and test them and see them and see exactly how that's going to impact the running application. The other thing that we've done here in this sample is we've actually integrated into our pull request flow. So when I create a new pull request against our sample repository here, we're going to go off and kick off another environment provisioning. This one is now a clean environment that lets the code reviewers on our team who are reviewing our source code also see how those changes look in an environment, giving us a chance to detect any potential issues before they get merged in with all the other changes in our team, giving our code reviewers much more confidence in not having to guess about what these changes are doing. Now, I have already a pull request I've created because it takes about 10 minutes for this environment to get set up. So let me go to that. And here I can see in that pull request, it's actually published out a unique URL for the environment that was set up at the time. And here I can see those changes running live. This gives our code reviewers a much richer experience as they're evaluating my changes. Finally, when I'm done with that, I can go and I can merge my pull request. And when I merge that pull request, our workflow is going to go and delete that environment for me. So I don't have any extra resources sitting around unnecessarily. And when this closes the branch, it'll do the same and delete the environment associated with that branch. Now, switching back over to the developer portal, I said there were kind of two key things that kind of make Azure deployment environments what they are. So coming back to the Dev Center here, the first is your catalog items. The second is your environment types. Here in catalog items, the catalog of items that you can provision are basically sourced from a Git repository. This can be any Git host that you're using, GitHub, Azure DevOps, GitLab, etc. And what the service is doing is it's scanning this folder for any Azure ARM templates that are there, along with the metadata that it sees to discover that this is a deployment environment, and making those catalog items available for your developers to provision inside of a deployment environment. This gives you the flexibility to collaborate through a GitOps flow between your development project team and your app infrastructure team. The second part of it is those environment types. So I'm going to come back to the podcast app over here. First, actually, before in the environment types, you can see we have several environment types. I have dev, prod, and this is what wires up and connects the subscription specifically for this project so that the right subscription gets billed for this particular project on the team, as well as the identity that's being used to provision these resources on behalf of my team. Last, we were able to give our engineering team contributor access to the instances of the environments that are created. So you can collaborate and just get permission to the environments that have been created without giving broad access to the subscription. And so if we take a step back here, we can actually see in our environments list all of the environments that have been created through our automated workflow from the CLI, as well as the manual ones that we've created by hand. We can actually drill into the resource groups for each of those, even see the costs associated with each of these environments that are running and manage them one by one. All right, well, so that was a big, quick overview of how Microsoft DevBox and Azure Deployment Environments give your developers the ability to self-serve their own high-powered, project-specific developer workstations, as well as their application infrastructure. These services today are both available in public preview. We encourage everyone to give them a try and get started. We have a blog, and we have plenty of documentation to help you get started with these services. Thank you very much, everyone, and back to you, Richard.